Hi everyone, welcome back to the channel, and today we'll solve Leetcode daily challenge problem number 1335, minimum difficulty of a job schedule. So first we are going to go through the problem statement, which is a little complicated I would say, and after that we'll check out the approach which we're going to follow, and towards the end we'll look into the code as well. So talking about the problem statement, it is given that we have to schedule a list of jobs in D days, and jobs are dependent on each other. That is, to work on the ith job we have to finish all the jobs j where uh, okay zero, like I is greater than j and j can be less than or equal to 0. Okay, and we have to make sure that there is at least one job on each day. So this is one of the constraints. The difficulty of a job schedule is the sum of difficulties of each day of d days. Okay, so difficulty of job schedule. Okay, so difficulty of job schedule is sum of difficulty of each day, and difficulty of a day is maximum difficulty of a day. So for example, in this case, in this example, let's say difficulty of day one will be the maximum value of the difficulty of the job done on day one, and what is it, sum of difficulty of a job is 2 plus 1, like difficult the sum of difficulties of all days. Okay, so this is the part. We will be given a array job difficulty and an integer d. The difficulty of ith job is at the ith index of job difficulty array. Okay, return the minimum difficulty of a job schedule. If you cannot find a schedule, then return -1. Okay, so let's check out the approach which we can use. So this is something which I have used. So first, talking about the approach, the objective. The objective is to find the minimum difficulty of job schedule. Okay, so what is the difficulty? So difficulty of each day was maximum of the difficulty of all jobs performed on any particular day. So maximum of d1 comma maximum of d2, and we want to minimize this, right? So we took the min method, minimum of difficulties on each day. Okay, there were two constraints. So if you see, we cannot have any day without doing any job, and job difficulty, like if you scroll down in the problem statement, you can see that job difficulty can be 1 or less than equal to 1000. Okay, so let's take an example and understand what we will be doing in the code, and we'll see the code at the end. For example, in this case, we had job difficulty array with 111 is in job difficulty of each job, and we have said that we have to complete these 3 jobs in 3 days. Okay, now coming to the solution, what we'll do, we'll use 3 variables: index, days, and current maximum. Okay, index will basically represents the job which we are currently. For example, 0 represent the 0th job. Okay, 1 will represent the first job, 2 will represent the second, the last job. Days will basically represent the number of days available to us, and current max is like the current maximum on any particular day. Okay, so these 3 variables will be used. So now what we'll do, for each day or for each job, what I can say is, like, there are 2 options. For example, this is day 1. Okay, so what I can do is I can put 1 in it, and there are 2 options now. Either I can end my day over here, or I can continue to add more jobs on it. Okay, so these are the 2 conditions which we are gonna look at. Okay, first one will be that the condition, the job which we done was not the last job for the day, and we will add more jobs in it. In the last, and the other condition would be that the job which we just performed was the last job for the day. So these 2 will be the conditions. Okay, so what we'll do, we will first check if we have already processed all the jobs. Okay, processed all jobs, right? If we have already done that, we don't have to process anything further. There is another check that is like it is possible that we are exceeding the days limit. So check if valid days are present. Valid days. Okay, next one is what we do for each day or for each call. We are gonna calculate the current maximum. Okay, and what we are doing in it, like current maximum, we are taking the current value of maximum, which was -1 at the moment, and our index was 0, right? So the element at 0 was 1. 0th index was 1. So maximum of -1 comma 1 was 1. So my value of current maximum will become 1 in it. So now, as I say, like there will be two conditions with each of the job. Either that will be the last job for the day, or we can add further jobs in the day schedule. Okay, so what we'll do for it, like if it is not the last day, then that means we don't have to decrement anything in the number of days, right? And if it is not the last day, we want to keep a track of the current maximum value, right? So this value will be passed in this call, and number of days will remain same, but we will increment the index, because yeah, of course, like if we have processed this, now we want to process the other element, the next element. Okay, so we will recursively call the same method dfs in with these values, index plus 1, days, and current maximum. The other condition which we talked about was if the job just completed was the last job of the day. In that case, what we'll do first, I'll explain the recursive call. So what we're doing, we are taking index plus 1, because of course, like you want to process the next job now. Days will be what? Days equal to days minus 1, because you have completed the job on one of the days. Okay, and now you are keeping the track of the other day. Okay, and I am reinitializing current maximum. Okay, so as you can see, the job difficulty was 1, right? So you can also take 0 here as well if you want. Okay, that won't be any issues. So this is possible. Now, to minimize that, what we are looking at is, if you see this part, why we are doing why we are adding current max is because if my this day ended, I of course know what was the current maximum, right? So I want to take that and add that value in the result of the next recursive call. So it can calculate day 2, day 3, day 4, and so on and so forth. So with each step, I will have the current maximum for each day, and we'll just move on. Okay, so this will be the results which will be returning at the end. This will return at the end, and we can also use cache, which I'll explain in the code how we are doing it. So let's go to the code now. Okay, so this was the code. Okay, so if you see over here what we are doing, I have put in a check. So this was a check where this is the check where we are handling that we don't have any days that that don't do any of the jobs. Okay, so if length of job difficulty basically means if the number of jobs is less than number of days, then we don't want to process anything, and we will simply return -1 in it. Okay, I'll explain this cache at the end, but let's just first go through the recursive calls. So this is the function which I have written for processing the records. In over here, if you see, this is the exact same condition which we talked about. If index is equals to length of job difficulty, then I want to return 0, which means that we have reached the last element, and we are returning 0 when number of days left is 0 as well. Okay, otherwise we will just simply return a infinite value. So this condition basically checks for we have processed all the elements, all the jobs, and we don't have any other days left as well. Next is a condition where we are checking if we have finished all the days or not. So if this condition is not getting satisfied, that mean that we basically have further jobs to be done, but we don't have enough days. In that case also, I just want to return any big value. So we can also send maybe 1001 from this point and 1001 from this point, because 1000 is the maximum value which we can have in the job difficulty level. And this is the cache. I'll explain this what we are doing over here. Now if you see, what we are doing to calculate current marks for each of the days is we are taking the maximum of current marks and the current element or the difficulty level of the current job. Okay, whichever is the maximum will be put in here, and as discussed, result will be minimum of recursive call with incrementing in index, keeping the days same and the current marks, because we want to have more elements, or we want to complete more jobs on the same day. And the other element is current marks plus DFS like recursive call with incremented index, decremented days, and resetted value of current marks. Okay, so this is because we have processed or we have completed day one values, and we want to process all other elements left in other days now. Okay, so this is it. Now talking about the cache, so what I want to do is, like, if we have these three values, there is the possibility that we can get the request to process the same value again, right? So what we are doing over here, we are preparing a cache with simple dictionary in Python, and we are keeping a track of the pair. For example, if we get the request to process any element at certain index on a day on with the same day and current marks, I'll check if the value, if this is something which I have already processed. If yes, I'll return that on the spot. Okay, we don't have to process anything further. And at the end, what we are doing, we are just returning the result. And like for the initialization of the recursive call, we have used 0 as the index because we want to process the first element first, d as the number of days available, and current max as -1. Okay, so this is the solution. Let's check out the test cases. Okay, just a sec. So the test cases got clear. Let's submit it for further solution now. Okay, so as you can see, the solution got accepted. And yeah, this was the solution, guys. Thanks a ton for watching other videos. Stay tuned for the upcoming ones. Don't forget to subscribe and like the channel. Thank you.